We're going to call our notes today 7.2.3 exponential functions. So this is like some notes that you can work on today's assignment, which are the actual notes. This is kind of like the pre-notes because I want to show you what you do need to know before you start working on the problems. So today we will explore the value of cars in an investigation called fast cars using exponential functions. There are some few vocabulary words. The first one will be depreciation. And that means when something is depreciating, it means that when we're talking about cars, it will sell for less than the price that you paid for it. So the value, what it means is that the value is going down, to put it in simple words. And then appreciation. Appreciation, when we're talking about cars, that means that the car will increase in value as time goes on. So, and that usually happens with like really old cars, like the classics and stuff. So the value increases. Okay, sorry, that is a weird S. Increases. Okay, so that we need to know. So let me give you like an example. We're actually gonna do two examples. So example one. Let's say I have a car that costs $21,000. So my car costs $21,000 and depreciates at, let's do 3% each year. So if I want to come up with my equation, remember our exponential equation is y equals a times b to the power of x, where a is the initial value and b is our multiplier. Now in this situation, we know that our initial value is 21 because that's what we started with. So I can say that A is $21,000. And I need to know, my car is depreciating. That means it's getting, remember we said that depreciating means that the value is going down. So we need to find our multiplier. That was not given to us. It was kind of given, but we do need to find it. So we know that it is going down at 3%. That means every year that goes on, we take away 3% from our car. So we can do our table and start finding out what 3% less of 21,000 is, or whenever we have percents, the first step is to turn your percent into a decimal. That is, we have 3%. To turn it into a decimal, we need to move the invisible decimal two times forward. So that would be here. That means we should have a space there, so it will become 0.3. That's the first step. The second step. Because we're depreciating, because it is depreciation, we have to take away from 1. We have to take away from 1. So we're going to take our... I did the wrong decimal, huh? We're going to take the decimal that we found from the first step. We're going to take it away from 1. So 1 minus 0.03 is equal to 0.97. And that is our multiplier. So if I go back to my table, I would be multiplying by 0.97 each time in order to find out the next number. So if I do that, the next number will be $20,370. And I can keep going. So now I know that B is 0.97. And therefore, I can write my equation as y equals $21,000 times 0.97 to the power of x. Okay. But what if it's appreciating? Let's pretend we have the same starting value, but now our car, let me write it down first. But this time it's appreciating by 3%. Okay. So same idea, but now this time it's appreciating. The difference for appreciating and depreciating would be the second step here that we talked about in the... So first, to find the multiplier, first we turn we turn the percent into a decimal. Remember, we already did it in the previous problem. We know that 3% becomes 0.03. Then, because it is appreciating, instead of subtracting from 1, we will be adding. So that's the difference. We will be adding. That will be 1.03. And so therefore, that is our multiplier. This happens whenever we have percents. We need to add 1 or subtract from 1. And that's for exponential functions. So if I wanted to write my equation, it will be 21,000, 1.03 to the power of x. And if I wanted to do my table, I know that I will be multiplying by 1.03 to find the next one. And therefore, the next number should be, let me multiply it really quick, 21,630. And I can keep going if I wanted to.